Okay, this is lesson 2.2e. What we're going to do today is we're going to get one of these pieces, and then from the information from that one piece, we're going to have to complete the rest of them. This is a lot like your test. So this first one talks about a state fair. It says you and your friends go to the state fair. It costs $6 to get into the fair, and then $2 each time you go on a ride. Consider the relationship between the number of rides and the total cost. So let's fill in the table. The X is going to be the number of rides, and this is going to be the total cost. Okay, so when we walk in the door and we haven't ridden any rides, it's already going to cost you that $6. So for every ride, you're going to add $2 onto that 6. So after one ride, we're at 8. 2, we're at 10. 3, when we add 2 more dollars, we're at 12. 4, we're at 14. 6, we're at 16. So let's go ahead and graph this. My graphs are super tiny. This is the number of rides over here. I'm going to go up by 2s. So here, I really can't number, but I'm going to go up by 2s here too. This is 2. You can't see the number. So 2, 4, 6, 8, 10, 12. They're not going to let me number here. So I'm going to start at 6, at 0. This is 1. After one ride, I'm at 8. It's going to go up that way. That's what your graph should look like. Okay, the equation, remember, here's our format. Our rate of change is the $2 for each ride, and our initial value, this is our rate of change, and our initial value is the 6. So we have y equals 2x plus 6. All right. So we're going to get asked some questions about this. What is the rate of change in the problem? We talked about that. It's the cost per ride, so $2 per ride. What does the rate of change represent in the context? It's the ride, the cost per ride. B, what is the y-intercept of your graph? Well, the place where you started, or your B, that is 6. What does that represent in context? Well, that's the $6 entrance fee. You pay that once, so it's a one-time fee. How would you change the context so the relationship between the total cost and the number of rides oh, excuse me, can be represented by this equation? Well, if we take away, here's our original equation. If we take away the B, that's the entrance fee, so there would be no entrance fee. How would you change the context so that the total relationship between the total cost and the number of the rides would be y equals 6? On your graph, let me go back. On your graph, that would be this. It would look like that. Well, that would mean you pay $6 to get in, and that's it. And you don't have to pay for rides. All right, let's move on to the next one. Okay, let's see what they give us this time. They give us the words again. It says you're taking a road trip. You start the day with a full tank of gas, and your tank holds 16 gallons. On your trip, you use 2 gallons of gas per hour. Consider the relationship between time and hours and the amount of gas in the tank. So we're going to put time here in hours, and we're going to put gas remaining. Oops. And this is gallons. Okay, so when we start the trip at 0 hours, there are 16. And obviously you use the gas, so we're going to have a negative rate of change here. So you use 2 gallons per hour. So in the first hour, I'm going to have 2 less, which puts us at 14. After 2 hours, 2 less, I'm at 12. 3, I'm down to 10. 4, I'm at 8. And 5, I'm at 6. Okay? So again, I don't think it's going to let me label the lower, but you're going up by 1 here. This is hours. Each one is worth 1. And then this is gallons of gas here. So I'm going to label this by 2's again. So this is 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So we're starting here at 16. We're not starting at 0 anymore. And then in my first hour, I'm at 14. My second hour, I'm at 12. Then I'm at 10. Then I'm at 8. Then I'm at 6. Okay? So now all we have left is the equation. So we need the rate of change and the initial value. Well, we said the rate of change was losing 2 gallons, so it's -2. And the initial value is where we started, the gallons we started with, which is 16. So when we go to this format, we have y equals -2x plus 16. Let's see what questions we have on this one. What is the rate of change in this problem? We already said that. It's -2. Okay? That means in the context that you are using 2 gallons of gas every hour. Okay. B, what is the y-intercept of your graph, and where do you see it in the table in the equation? Well, let's go back and take a peek. Here's where you see it on the table, where your x is 0. That 16 is your y-intercept. On the graph, you see it right here, where the line crosses the y-axis. So 16 is your y-intercept. On the table, where x is 0, the y value is your y-intercept, or your initial value. On the graph, it's where your line crosses the y-axis. Okay, letter C. How would your equation change if your gas tank held 18 gallons of gas and used 2.5 gallons of driving? So this is your initial value, and here's your rate. So we would have y equals -2.5x because we're using the gas, and we started at 18. What would the changes do to your graph? Well, you would start higher up, and the line would be steeper. All right, this time we get a table and no context, no equation, and no graph. Okay, so let's go to the equation first. We need our rate of change and our initial value to get the equation. So since we're going up by ones, this has to be by ones, we're going to look at the change. So I'm adding 2 here, I'm adding 2, adding 2. So our rate of change is 2. And here's where we find our initial value. X is 0. That means our y value is the initial value. So our equation is y equals 2x plus 7. All right? So I am going to go up by 2's. Wait, I'm going to make that 4. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 20, 26, 28. So I'm going to start at 7, which is right in between. And then we're going up, right? So I'm going to go up to over 1. So I'm going to graph my line. All right, context. This you can use your imagination, but you know you have to start with 7 and go up by 2. So I'm going to say Joe started with $7 in his savings account and saved $2 each week. So there is my context. All right, A, what's the rate of change? Well, that's the amount that he saved every week. So in my context, it's Joe saves $2 every week. What is the y-intercept of your graph? It is 7. And where do you see that on the table? Here is where you see it on the table. And here is where you see it on the graph, the place you start. What does it mean? It means Joe starts with $7 in his account. How would you change the context if the rate was 3? Well, that would mean instead of saving $2 a week, Joe would be saving $3 a week. Okay, that is it for this part. There'll be a second half to this, and you can finish up your notes then.